Hello. Hello. So, I'm working on the electronic part of this machine now. I've made a command decision to do something kind of crazy. I'm going to take a look at using a microcontroller that I have and an 8-port relay board, which is pretty cheap, and some digital thermometers, which are also pretty cheap, and replace the 70s era electromechanical stuff that previously controlled this machine. So, this is the old control box, which will be the new control box. It's actually a drawer. It slides into the spot under the door, and over here was the motor or the heater contactor. This guy, which when the booster heater needed to be heated up, power would go across these coils and close these contacts. It's a split phase 240, so there's two poles. I would like to reuse that, except for that's a 240 volt contactor for some goddamn reason. So I'm going to swap that out for a 120 volt coil. The machine was controlled by this cam timer. As these cams spin around, it hits the various switches and controls the various functions of the machine. And this was wired. These are both, or all 8 of these are double throw switches, and they were almost all wired up into this elaborate state machine with this maze of wiring, and it's kind of a mess. It was kind of a mess when it was all in the box too. And then the real purpose for taking this apart, other than to get all of the electronics out of there so I could scrub it out and get rid of the dishwasher stank, is by having all of that extra stuff, all of this extra electronic stuff, I was able to rig up a quick test rig to make sure that this motor worked properly. Now, I had previously, I wasn't able to verify that the motor started in both directions when it was installed at the customer account. So I've wired this up such that we've got the start relay here, which is a special type of funky relay. And I have one of these switches wired up for power and one for direction. And this has to be sitting upright because it's gravity thing. When this motor starts, the main running coils, the main running windings inside the motor are stalled out. So all they're doing is drawing a bunch of current and making a bunch of heat. What this guy does is it has that big fat coil in there, and when the main windings are drawing a large amount of power, this thing assumes that the motor is stalled, and it pulls closed these two contacts, and those operate the start windings. And there's two start windings in here, a clockwise and a counterclockwise one. And that's what this switch controls, whether the clockwise or the counterclockwise windings are fired. So if I switch this on, I did have a little moment of panic here where it wasn't quite starting properly, and it's because this coil had a lot of oxidation on the contacts. It wasn't working properly. So if I switch this on, it should spin right up. Just like that. That's running pretty quiet. So that was clockwise. If we flip this switch and turn it back on, now it's running counterclockwise. So it looks like the upper bearing is pretty good, and it's not making a lot of noise. I probably would like to replace that start coil just because it's kind of crappy, but maybe not. We'll see. And so this is kind of the big beginning of the adventure for the control. The fact that this motor is good in both directions means that I don't have to buy a whole new pump, which is good. And we'll kind of take it from there.